Hello, I'm Grant Swain of Curated School. This is video lesson 3 of series of 9, and today we'll look at the fundamental building blocks of electricity: voltage, current, and resistance.
Voltage is measured with a voltmeter, which is typically part of a multimeter. Current multimeters, such as the one on this trainer, use digital displays and update about 10 times a second. Often called a digital multimeter, or DMM, or sometimes even called a digital volt ohm meter, DVOM. Now, this trainer is equipped with a basic digital multimeter, and let's set up this meter to measure voltage. So we're going to put the selector switch on 20V, and there's actually two parts to this. We also have to put our test leads in the correct ports. The middle COM, the COM port, which is short for common, is always used. So let's just start with a black lead there, and on volts we're going on the right port, which is a volt ohm port. This is important because we're measuring with a voltmeter. We're going to take the voltmeter and touch the circuit in two places. We can't affect the circuit. So in this configuration, uses two port. This has nothing to do with selector switch. In this port configuration, this meter has a lot of internal impedance, a fancy word for resistance, but it basically means that this meter will not draw power from the circuit that you're measuring the voltage. So it's important that you use the right port when you're doing volts. So let's go ahead and set up and take a look at in this case, we'll just do source voltage, which is the voltage applied to the circuit that's going to push current through the wire. So we'll come in and build a simple circuit. This is a power supply. This will be it'll be the same thing as the positive post of the battery, and then a ground. And this is a way that the typical automotive wiring diagram would have actually power at the top, ground at the bottom, and current flow on top to bottom. So we'll do a simple, this uses LED. The camera likes it a little better. So we'll just bring a power over to our light emitting diode and come out and go to a ground. Turn on the unit. This meter is attached to the trainer and is powered by the trainer. And we have our LED. So now, there's basically two types of voltage. There's source voltage that's going to be applied to the circuit, and then you're going to actually, out on the circuit, you'll find the voltage, which is called voltage drop. We cover that in an entire separate class. So remember, a voltmeter is measuring the difference potential on 2 points on a circuit. So, and we're not going to change the circuit in any way. We're going to approach the circuit with two test leads and touch it at 2 points and see what the difference potential between the 2 points are. And that's like the difference between like water flowing through a pipe. With a stricter, there's high pressure on the upper side, lower pressure on the lower side, and we're going to be able to see that on the voltmeter. Now, like I say, in this particular, we'll keep it simple. We'll come over here and look at source voltage. So we'll drop in on our negative post of battery and our positive post of battery, and we have a source of 13.74. And that's pretty common. We call it a 12-volt system, but the car's running and the charging system's working. It has to be higher than the battery's voltage, so the current will go into the battery and charge it. But that's very typical voltage you'll see in the automotive world. It's also called a parallel relationship. The meter is parallel to the circuit. It touches in two places. So this is called a parallel relationship, and you'll see when we look at current here later in this course, later in this lesson, that it has a series relationship. With voltage, the unit of measure simple is a volt, and we're generally dealing with a full volt, millivolt. Milli means 1,000, so we go under a volt. if we're looking at 3/10 of a volt, it sounds more professional, and typically the standard is less than a volt, you go to milli. So instead of saying 3/10, you say 300 millivolts. And you will find kilo, which is 1,000 kilovolts in the ignition system. That's a whole different type of electricity we don't touch in this particular series. So a modern day automotive system could have 25, 30,000 or even more, 40,000 kilovolts, 1,000 volts on the ignition system. Different type of voltage. Current is the actual flow of electrons to a conductor, and current is directly proportional to the source voltage, meaning that all things were equal and the source voltage were to increase, then like water pressure increases on a pipe, more water flows in a electrical circuit, a higher voltage, more current flows. Voltage increases, current increases. Voltage decreases, current decreases. And current is measured with an ammeter, which is going to be one function of a digital multimeter, such as we have here on this trainer. When measuring current, we have to make some changes. Number one, we'll change our selector switch to 10A. We have to move this lead out of the right port, which is the volt-ohm port, to the left port, the 10A port. The meter takes on a totally different characteristic. Remember, we talked on a voltage mode. COM port to the V port has a high impedance. We go from COM port to the A port, there's no impedance. Actually, inside this meter, if you took it apart, you'd find a shunt. There'd be a conductor bar between the COM port and A port. So current goes right in and right out with no resistance whatsoever, because to measure current, we had to put this meter in series with, we actually had to open the circuit up. Now the current in the circuit go through the meter and back out. So there's zero resistance. You can think of this meter as having the characteristics of a conductor. This is like a piece of wire, so to speak. And the way it measures current is close to that shunt on the inside, there is a sensor that's picking up magnetism. Remember, there's a close relationship between electricity and magnetism. If you have current and through a conductor, you have a magnetic field on the outside. The higher the current, the stronger the field. So it picks up on that magnetic field off that shunt. Moral of the story is we got to be careful. If right now, I have a live little circuit going on. This LED has 12 volts applied across our source voltage. If I were to come in here and tap in like we're going to measure voltage across this bulb, I'll be providing a path right around the bulb with no resistance. And electricity would not flow through the bulb, it can go through the meter. So I would effectively create a circuit with no resistance, and we would have infinite current. The current would ramp up and blow a $10 meter fuse, and looks unprofessional. It takes 15 minutes to fix. So we're not going to do that. So with current, we've got to open this circuit up. Now it doesn't matter where I do that. The current is the same everywhere. Remember, all the electrons are hopping atom to atom simultaneously. So we'll open up the circuit. We'll catch on the ground side. Light goes out. We'll now have an open circuit. The current's going to flow. Let's bring the current into the amp port and come back out this ground. So we'll just take this one out. And we're live again, and we see 0.01. That'd be 10,000ths of an amp, or remember, we'd like to go say 10 milliamps. So current was flowing through the bulb, into the meter, back out of the meter, and over back to ground. A couple limitations of using a digital multimeter such as this to measure current. Number one, you have to open the circuit up to get into it, and that's not all that easy to do. If you're on an automotive environment, you're having to pull pins out of a connector. You don't have to go in there and cut wires, so we don't do that. So it just takes a lot more finesse sometimes to get the ammeter in series with what you're trying to measure. And for that reason, and in fact, there's a second reason. Our second limitation is most of these are about 10 amps. Remember, the current is going through the meter. You can't put 30, 40, 50, 60 amps through a meter, at least not in a typical automotive digital multimeter. So what's pretty common in the market is an amp clamp. You can put a clamp around a wire, and it senses the strength of the magnetic field on the outside, and actually that would feed into as a voltage signal, and you'd convert that to current. I just want to bring that up, that there are some limitations on the 10 amp max and the fact you got to open the circuit up. This to kind of wrap up, it's kind of interesting. Let's look at why most of these cities have spent a lot of money to change the incandescent traditional street light out to LEDs. This is an LED marker light, or the glove box light, something like that. And this is the equivalent of a traditional bulb with a filament. So now this light's fairly bright and it's cool. I can touch it, totally room temperature. If we move over here to our traditional bulb with a filament, we notice it's not any brighter, and maybe not quite as bright as it's amber instead of white. But look over here. Now we went from 10 milliamps to 270 milliamps. So huge difference. So if this was 300 street lights and you're changing this much between the current with the LED, big savings in current. And to wrap up on current, current is really actually what produces work in the electrical arena. Current can actually do two things. You can flow current through a special engineered piece of material called a conductor. They'll either put off light or heat, or a little of both. This is handy, that when the plenty of applications of light and heat for electricity, or we can create magnetism. Anytime current goes through a wire, it creates a magnetic field. We can wind that into a coil, create strong magnetic fields. And so magnetism is going to cause electric motors to work, actuators to move up and down, like power door locks. And power windows have motors, starters, alternators, solenoids. All these things are off of magnetism. And we can come down, and we have a little motor here. This little motor is all operated because of magnetism. And this little guy here is pulling 30 milliamps. And we'll see if we cause it to do more work, we have an increase in current. So that's a wrap on current, and the next topic coming up will be resistance. And now to the last building block of basic DC electricity, resistance. Resistance is a force that reduces the flow of electrons. Much like a restriction in a pipe would reduce the flow of current, resistance in a circuit reduces the flow of electrons. Resistance is measured in ohms, and we use an ohm meter, which is also typically part of a digital multimeter, such as the one here provided on the trainer. We changed back to the COM resistance, we changed back to the volt resistance port on the right, and we're down here at 200 ohms. Ohm is the, looks like an upside down horseshoe, omega. And now we get ready to measure resistance on a circuit that can't be live. We notice we have a bulb going here. It can't be live, and it can't be connected. We can't really measure resistance of this bulb while it's connected to anything else. It will skew our resistance numbers. So we have to disconnect the component and then come in here. Now it doesn't really matter. In this case, it's just a filament, which way we go. As far as polarity, it doesn't matter. And we're looking at basically about 6.9. Now, you notice how it's slowly dropping. The reason it's slowly dropping is because the filament's cooling off. The resistance is changing. Which brings up a point that in the real world, you're not going to fix a lot of cars with an ohm meter. I very rarely use one in my diagnostic world. Often you'll find resistance number looks good, but it's still a bad component. And also, if you're looking for resistance on a live circuit, we use voltage drop, which is much better than an ohm meter. So we'll get into all that in another lesson. So we have to disconnect the component, plug it directly. Now we're down to 5.2 and dropping because the filament's cooling off. And for that reason, like I say, you have to disconnect the component. You have to, you'll just find that if you had to give up something, you give up the ohm meter. And we'll wrap up the resistance by talking about the 5 features, the 5 things that affect resistance. Number 1, and this is generally related to like a conductor, is the length. Obviously, the longer conductor, the more resistance is going to introduce. So if you're wiring up something extremely long wire, you need to consider maybe going to a larger gauge wire. And speaking of gauge wire, the diameter of the conductor. So the length of the conductor, the diameter of the conductor is going to affect the resistance. The temperature, when it's a physical science thing. When a property gets hot, it's going to increase in resistance. Just like the bulb we saw when we first hooked up to it. It was up above 6 ohms, and now we're down to 4.8. So that's another thing. If you measure something cold and measure something hot, it's 2 different numbers. The physical condition of a conductor also will affect the resistance and the type of material. Is it copper? Is it aluminum? Is it steel? That's going to affect the resistance of a conductor. And now that's a wrap on our 3rd building block, resistance.
For more information about training products offered by Gearhead School, go to gearhead.school/courses.